This video is about perspective convergence, and what I want to show is why the sun looks close. I want to show why the sun looks close when it's casting out its crepuscular rays, and I want to show how the underside of the clouds are lit, and I believe perspective convergence also shows us how the sun goes into the ground when it sets. And last but not least, I'm going to show you how the sun path matches the flat earth model and does not match the heliocentric ball earth model. The sun is close, about 3 miles away. How do I make that claim? Well, I make that claim because of these convergence lines, right? Everything converges at the eye level of an observer standing on the ground. So for the average height person, it's about 3 miles out. All these lines converge. All of these parallel lines and planes will converge at one's eye level. So how far out does this convergence take place for the average height person? Well, they say about 3 miles out. Well, it could be further, could be 4, 5, 6 miles, I don't know, but let's just go with the 3 miles, right? Okay, now, where in relation to the observer, or his body, where does this convergence happen? Well, it happens at the observer's eye position. In this case, it's the eye level of the observer. So in this picture we have the ground or the water ramping up following the convergence angle. And when the ramping ground plane intersects with one's eye height, that's when one's horizon is formed. You can see objects beyond your horizon, but you can't see any more ground at that point. And that's why objects beyond the horizon are blocked from the bottom up. And that has nothing to do with any sort of curvature. It's all perspective convergence on a flat plane. That's where everything converges. And that's where your depth perception stops. Your horizon then, and the convergence that takes place occurs about 3 miles out. Here's the crazy part. Visually, clouds, sun, moon, stars, airplanes, everything would go then to your horizon because that's where the convergence point is. That's where it would visually go from your perspective. Now, when I say visually, I don't mean some visual apparition or some kind of illusion, optical illusion, so much as I just mean perspective and convergence, right? Perspective convergence. Because when we see the sun, that's the converged path. That means it's the actual path, but it's converged. So the sun is actually traveling on that path. That's close. That's not far. I don't know how far it is, but it's close enough that we can see the converged path of the sun in our atmosphere. Now, if we also take a look at these crepuscular rays, I took a lot of flack. I put out a video called Crepuscular Rays Prove Flat Earth. You know, in there, I had people saying, oh, you know, what are you saying? The sun is right there above the clouds? And, you know, I'd say, yes, the converged position is right there above the clouds, right? So, you know, they say, well, can you run into the sun? Or how come you can't fly above the sun? Because if you try to go where the sun is, right, if you try to go up, well, then you've just changed your point of view, right? Your perspective has changed. Your position relative to the sun has changed. So the sun, as you move up, is going to change its position, right? And it's going to move more towards its actual position. For instance, like these flowers, right? These flowers are going out in rows and rows and rows. Now, if, let's say the flowers extend out 100 miles to the right of me and 100 miles to the left of me, and they go far enough, they'll converge, and they'll visually converge about 3 miles out. That's where the convergence takes place. So now if I said to you, go pick the last flower in this row that's 100 miles to the right of us, that's going straight out parallel to these rows, go pick that flower. Okay, now it appears to be right in front of you. Now, could you go right in front of you and pick that flower? No, you can't. You'd have to go out there however many miles that is, and then turn right and go 100 miles and then pick that flower. But visually, it's right there in front of you because that's where the convergence is. That's where you see it because it's converged. That's perspective. No other illusions other than that. It's perspective. When you say, I'm going to head straight out to pick that flower, well, it's not going to happen because every step you take, you're starting to change your perspective or your point of view. So as you move out towards that flower, all those flower rows are going to start to spread out. You're going to start to see wherever you are, they're going to be parallel, and then they're going to converge in front of you. And actually, if you get far enough out, you're going to look back to where you started, and it's going to look like this, back the other way. It's going to be converged where you were. You see how that works? So the sun is the same way. You see the sun from the ground, that's the converged position of the sun from your perspective on the ground. But if you try to go up to the sun is going to move more towards its actual position. And it's not that much, it's not that far away. Now, look at this sunrise right here. You're going to tell me that's 93 million miles away. And then look at its setting. That's a close sun cruising over our flat Earth. And the higher up you get, I've found that the sun looks lower and it looks closer. The sun is lower than the clouds from your perspective on the ground. So the sun is visually lower, and it's structurally, meaning it's of your perspective matrix here, your perspective structure, I like to call this. The convergence point of this structure, which is also your horizon, is only 3 miles away, and it's sitting on the ground. And that sun sitting on the ground will light the underside of the clouds from your perspective. Now remember, this is just the illusion of reflected light between the observer and the light source. No observer present, and this doesn't even take place. That's a head scratcher in itself. It's kind of like if a tree falls in the forest and nobody's there to hear it, does it make a sound? Well, it only makes a sound if you have apparatus to perceive it. The eardrum and the sensations of sound waves or whatever. They're only what they are if you have an apparatus to receive it. So it's kind of like the sun and the light. You need eyes and you need consciousness to be able to receive this stuff, to perceive this stuff. Okay, the clouds are lit up. And specifically, the underside of the clouds are lit up because they are acting as a mirror or reflective surface. And none of this, like I said, is real. It's just a reflection. For instance, look at these two guys standing on the shore. The guy on the right sees the water lit up between himself and the sun. The guy on the left, standing a few feet away, also sees the water lit up between himself and the sun. But the guy on the right does not see the lit up portion between the other guy and the sun, and vice versa. This guy doesn't see his water lit up. So the lit up water isn't real. The water isn't really lit up. It's just a reflection. Just like when you see yourself in a mirror, you aren't actually in the mirror, and someone else standing at a different angle to the mirror who looks in the same mirror at the same time may not see you in it at all. They may see themselves or something else entirely, depending on their point of view or their perspective or their angle. So when you see the clouds lit up, they're not actually lit up. They're reflecting the sunlight just like the water is, except the clouds scatter the light because they're not as solid a reflective surface as the water, and they're not as flat like the water is. So the clouds here, you can see them, they're kind of orangey in this picture, but on the water, it's a deep red. That's because the water is absorbing, the darkness of the water is changing the orange to more of a deeper red. But again, none of that is real. A viewer on the other side looking toward the shore may not even see the red water. It all depends, where you're located. Definitely the orange under the clouds there, that's all, you can see that it's hotter white in line with the observer. So I'm saying that doesn't exist, except for that an observer is there to see it. Okay, so now to prove that the underside of the clouds being lit is in fact a perspective issue, let's go up 4, 5, 6 miles. Let's rise straight up and see what'll happen. The clouds will now be below us, and the tops of the clouds will now be lit up. Okay, and so as we rise up, the sun rises with us because the sun's on the horizon, and the horizon always stays level with your eyes. So the clouds now are going to start going down and get lower and lower below you, right? So now from your perspective, as you look, the tops of the clouds are lit up. And if you could see the bottoms of the clouds, they would not be lit up. Same as when you were on the ground. When you were on the ground, you saw the bottoms of the clouds lit, but the tops wouldn't be lit. And it's all just a reflection because it just changed your perspective and it changes. Okay, let's talk about how the sun goes into the ground. How does it go below the horizon? Well, again, the convergence lines are the key. In order for convergence lines to all converge at one point, and these are the horizontal lines that are stacked up. They're kind of stacked up on your vertical axis, but they're horizontal lines. The only way they can all point at the same place is each higher one has to progressively angle more and more downward as it goes away from you, right? So that's how it visually all go to the same place. So the sun is on one of those lines. The clouds, the sun, moon, and stars will all go down into the ground. Now, here with these blue slats, right, these blue planks, I put lasers on them, essentially, these yellow lines. Now imagine those are tight lasers that don't spread out. And these tight lasers are shooting out toward the horizon. They're angled into the ground. So what's going to happen to them? They're going to go into the ground. From your perspective, they're going into the ground. Even though they're parallel lines, right? But they're converging. And you're not going to see them. They're going to sink into the ground. And that's exactly what the sun, moon, and stars do. Look at them. They're angled into the ground. What are they going to do? Are they going to all of a sudden hit eye level and straighten out? No, they continue down into the ground as we witness with the sun, moon, and stars. That is your flat earth celestial perspective. That is your perspective matrix at work right there. Your perspective structure. It does it to everything. This is the reality. Right? And now I can say one more thing. Now you might be saying, yeah, but wait a minute. The sun isn't going on a straight line away from us. The sun's curving. Yes, that's true. The sun's curving. And let me show you how perspective works with that. In the center of the circle, let's say the sun is circling over you and you're at the North Pole, you'd be at the center of the circling sun. Then you'd see the sun go around you 360 degrees. But not many of us can be at the North Pole to see that, right? But that's what happens, right? Well, most of us live as near the path of the sun. So as you move towards the path of the sun rises. And the parts that are further away from you, the sun lowers. But now head towards the path of the sun and watch what happens. The other side dips down and that goes below your horizon. So what you get is this pyramid shape. The sun comes up and over you, and it's slanted at an angle. The sun's path is the circular motion plus the up and down of perspective, and it causes it to slant.